You're listening to EUAudio. Listen, learn, lead. Combating obsolescence in military applications. Manufacturing for the defence sector is governed by complex regulations and requirements, coupled with the long lead times for parts and equipment. Good obsolescence management is a powerful weapon in a manufacturer's arsenal when it comes to overcoming these issues. In the defence sector, correctly managing ageing equipment is no simple feat. Systems such as military aircraft, naval solutions, and missile defence systems are expected to remain operational over several decades, but their components commonly have an operational lifetime of 5 to 10 years. To complicate things, defence is a highly regulated field, and using components that have not been previously approved can be problematic. If a component breaks and an exact replacement is not available, installing a different part means that that entire system might have to be retested and recertified. This adds extra costs and delays before the system can be back up and running. The scale of the problem. According to Professor Peter Sanborn, Director of the Mechanical Engineering Department of the University of Maryland, it is not unusual that 70 to 80% of electronic components in a military system become obsolete before that system enters service. This is due to the long lead time that characterises the defence sector, where every phase of a component's design, production, and installation is strictly regulated. Obsolescence is a costly business. Though its exact cost varies on a case-by-case and country-by-country basis, evidence shows that its impact on the defence sector is significant and that solutions to mitigate its negative consequences are urgently needed. For example, the US Navy estimates that obsolescence-related issues cost them up to $750 million annually, a huge amount that inevitably impacts American taxpayers. A holistic approach to obsolescence management. The life cycle of a defence system is divided into 6 phases: concept, assessment, demonstration, manufacture, in-service, and disposal, the so-called CADMID cycle. Obsolescence can occur during any of those phases for any component of the system. Therefore, a holistic approach to obsolescence management has to be implemented already in the early stages of any military project. There are 2 approaches to holistic obsolescence management: reactive and proactive. The reactive approach consists of taking measures to substitute or repair parts once a breakdown happens, while the proactive approach is based on constant monitoring and planning to prevent breakdowns from occurring in the first place. A proactive approach is, of course, preferable in that it allows manufacturers for the military sector to plan in advance, sourcing spare parts where it is most convenient and minimising downtime due to unexpected breakage. There are 3 main areas in which a proactive approach to obsolescence management can be beneficial: design, supply chain, and maintenance planning. In the design phase, it's best to leverage open system architectures and modularity so that parts can be substituted more easily. In the supply chain, it's important to have partnering agreements with a trustworthy supplier that can deliver parts quickly and efficiently, minimising downtime. Finally, it's important to have an obsolescence management plan in place. To help with that, hiring an obsolescence manager can be a good solution. These professionals can help track the life phases of military equipment, monitor the condition of machinery and tools, and plan necessary maintenance before breakage even happens. EUAudio is brought to you by EU Automation.